Okay, so we're going to start with just a couple of the basic functions, okay? We always, every time we start a function, we start with the parent, all right? And this first one isn't really the parent, but it is a special function. It's called a constant function. So that is where f of x or y equals some constant, c. And a constant is just a number, right? Like 4, -2, 0.75, okay? So where c is a constant. I'll put c is a constant. And in the game, you saw that as a horizontal line, okay? So for example, I'm going to graph the line f of x equals 2. So, and you can use your ID badge as a straight edge. I'm going to just try my best on the board here, but you can use your ID badge as a straight edge. And this would be f of x equals 2. Okay, and we could do any number of those, right? There's an infinite amount of constant functions that we could come up with. Like I could have f of x equals, I'm going to call this one -1/2. That's supposed to be a zero slope. Didn't draw it too well. Okay? All right, so that's a constant function. It has a slope of 0 because it doesn't change. Okay? All right, anybody know what this D and this R mean over here? Domain and range. Yeah, domain is all of the valid x values in our function. Okay? So what kind of x's do we have in both of these? Well, you look at the arrows. Where are the arrows going? Left and right, right? So does that mean all the numbers?
Yes.
Yeah, all the x's to the left, all the x's to the right. So the math way of saying all the numbers is all real numbers, right? Okay. However, the way you say that is very specific. We're using set notation. So bear with me. This is the full notation for all real numbers, okay? Curly brace is a set brace, okay? It says I'm opening a set. I'm going to say the set of all x values such that, so that line means such that x is an element of all real numbers, and that is a Greek letter. Just think of it like a C with a little line in between, or like a curved capital E. Okay, so that literally translates into x such that x is an element of all real numbers. Okay, that's like the full name. Okay, you want to be 100% correct, you put that. There is a shorter way though. I don't know how many of us like to write that over and over again, especially if we don't have the best handwriting. Okay, you can also say that just like this, just with the R with 2 stems. That means the set of all real numbers, okay? I think I might know which one you prefer, but I'm showing you this, so you know that that is the real notation, okay? And then Y is the range, the set of Y values in our function. So if I look at each function, are the Y coordinates all real numbers? No. Every point on our constant function is constant, right? Every y value is the same. So this is, the y is always 2. And this one, the y is always -1/2. And in general, for our constant function, we can say the y is always c, right? Okay, now here's how we write that. The set of all y values such that, and y is always c, right? So I would say y equals c. The set of all y values such that y equals c. Okay? So you're going to be introduced to a lot of new notation in our class as well. Okay, now we can go over to the parent function, the identity function. That's when x and y are the same thing. When x is 2, y is 2. When x is 3, y is 3. F of x equals x. That's our parent function, okay? So when x is 0, y is 0, right? When x is 1, y is 1. And we start building the line that has a slope of 1 and a y-intercept of 0, right? This is our parent function. Okay? Every other line that we graph is just some transformation of this one. And we have all these different forms that we like to use interchangeably to help us graph these, okay? All right, domain is x's, so ask yourself, can x be any number on that?
Yes.
Yeah, okay? So x is all real numbers, so we can just say it the short way with a two-stemmed r. And since y equals x, if x is all real numbers, what does that mean about y? Also all real numbers. Okay? Okay, and then now we just are getting into the forms of a line, okay? Now the steps, like how you actually make the graph, are given to you in these notes, okay? I'm only going to do one example of slope-intercept form because it looked like we had a pretty good handle on that, okay? But if you forgot some things, m is the slope, b is the y-intercept. These are the steps to graphing. You do the y-intercept first, then the slope, and then this is important, make the line fill the grid, okay? We want to make sure we do that. So I'm going to do number 3. But you will find on Schoology, if you want to see all of them, that it will be there, okay? You can see all of those. Okay, so y-intercept. That's coming first because that's what we're going to plot first. So that's our b. Anybody know the b in this one?
3.
3, yep. So our y-intercept is 0, 3. Because in an intercept, the other coordinate is always 0, okay? So I'm going to graph that, y-intercept, 0, 3. And then the slope is -1/2. So we know that that means the rise is -1 and the run is 2. And when your rise is negative, you're going down, but you're going to the right. That's what's going to create that negative slope. So down 1, right 2. Down 1, right 2. Okay, and you make that fill the grid. So I've run out of room on my little grid, okay? So I'm gonna go back to my y-intercept, and I'm gonna do the exact opposite to fill the grid the other direction. So down and right will turn into up and left. So up 1, left 2. And once I can't fill any more points on my grid, then I can connect those. Okay? All right. Slope-intercept form, you good with that? I want to spend more time on the harder ones, the ones that we showed some trouble with. Okay, standard form. Okay? Standard form looks like this. ax plus by equals c, where a, b, and c are integers. So what that means is there are no fractions. So for something to be in standard form, there are no fractions, okay? It's a fancy form, and an easy way to graph in this form is to graph with intercepts, okay? So remember, in an intercept, the other coordinate is always 0, okay? So if I want to find the x-intercept, that means the y is 0, okay? So in the x-intercept, I know it's going to look like something, comma, 0, because the y is always 0. And if I know that the y is always 0, a quick way to find it is just to plug in 0 for y, right? And then what's anything times 0? 0. So it just kind of goes away, right? So 3 times 0 is nothing, 0. So then I'm looking at 2x equals 6. Divide by 2, x is 3. So the x-intercept is 3, 0. And that's what they did here. They just plotted 3, 0. Likewise, if I want to find the y-intercept, that means the x is 0 the x is 0, and I'm trying to figure out what the y is. And if the x is 0, we just go in the equation, plug in 0. Anything times 0 is 0. So we're just looking at 3y equals 6. Divide by 3, y is 2. So that's how we get a y-intercept of 0, 2. Okay? Okay, so let's practice that. Let's do that with number 7. Okay? All right, if I want to find the x-intercept, that means which coordinate is 0? The y. Okay, so I'm just going to fill that in right now. And actually, why not? For the y-intercept, I'll make x 0. Okay, so for the x-intercept, I'm going to make the y 0. And if I'm going to make the y 0, doesn't this 3y just disappear? So I'm looking at x equals 3. Okay, so the x-intercept is 3, 0. And we can plot that. Okay, now we can do the y-intercept as well. The x is 0. So we plug in 0 for x, essentially goes away, right? Looking at 3y equals 3. If 3y equals 3, what does y equal? 1. Okay, so yeah, 2 points make a line. However, remember our rule, we want to make sure that our line fills the grid, right? We want to fill with more points. So how can I put more points? Well, I can count the slope, even though it wasn't given to me in the problem. Can't I just count it, the rise over run? My rise is down, so negative 1 over 1, 2, 3. I'm just going to make a note here that my slope is negative 1 over 3. And then if I know that, I can continue plotting more points. So I can't really put any more points to the right, but I can go up 1 and left 3 and get 1 more point so that I fill my grid. Okay? Okay, can you guys take a second and try that with number 8? There's nothing tricky in number 8. I just want to see if you can do that, and then we'll come together for number 9, okay? I have to put in my attendance real fast. Let me do that. Okay, when you think you got it, you can check up front to see if you got the same thing I did. Now, what a lot of you probably did with this in Algebra 1, since they pushed like Desmos, or maybe not, maybe when you took it in middle school they didn't, but they had you convert this to slope-intercept form. Yeah, I mean, you can do that too, okay? You can do that too. And sometimes that's actually the better choice, honestly. Sometimes that is the better choice. But this is also just kind of a quicker way of doing that. Okay, any questions about any intercept or how we got the slope? You just counted? Okay. Okay, then we might get to something that's a little weird, like number 9. I don't know if you looked ahead or not, but you see that this one doesn't work out as nicely, right? So if I want to do the x-intercept, again, that's when y is 0. So if I plug in 0 for y, we're looking at 3x equals 8. And then we run into a little bit of an issue, right? Because 8 doesn't divide by 3 evenly. That's okay. That's still the x-intercept. The x-intercept is still 8/3. And what is 8/3? It's like 2 and 2/3. It's almost 3, right?
Yeah.
So it'd be like right here. Okay, and then we can get the y-intercept. That's where we make x 0. So we plug in 0 for x. 3 times 0 is just 0. So we're looking at 2y equals 8. So y is 4. And that one's nice, right? That one worked out nicely. So this one might be one where you say, you know what, I think I would just rather convert this to slope-intercept form, right? And I mean, you can. But I want us to try to find a shortcut. So I would not like lean on the fact that I'm just going to connect those points, because that's not too, it's not too accurate, right? Look at these over here. Let me highlight them a little bit. Look at the equation, and look at the slope. And look at the equation, and look at the slope. Even though standard form does not give you the slope, can anybody see a shortcut of getting the slope from the standard form? So like if I were to say in general, any equation in standard form, we can easily find the slope by doing something. Anybody think they know what that is? Abigail?
X over y, and then you change the sign, like you flipped.
Yes. Yes. And what were you going to say? Same thing? Yes. So it's, and I'm going to say it's the coefficient. So it'll be a over b, but negative a, or opposite a over b, right? So if a is 1, opposite that is negative 1 over b, which is 3. A is 2. So opposite that is negative 2 over b, which is negative 3. Negative 2 over negative 3 makes positive. Okay, so m, the slope, is opposite a over b. So that's a way to get the slope from standard form without having to convert the whole thing. Okay, so why do I bring that up for number 9? Well, because I got a good y-intercept, let's figure out the slope. If the slope is opposite a over b, in this problem, that would be opposite 3, or negative 3, over 2. And if I know that, then I can count that slope from my y-intercept. I can go down 3, right 2. Down 3, right 2. Down 3. And then that like estimate of our x-intercept should come close, right? You should go, okay, I estimated that pretty good, okay? But we always want to have accurately plotted points, okay? So this little shortcut is going to come back. We're gonna come back to it, especially tomorrow, okay? All right. So far, so good? Yes.
So only the top number becomes the opposite?
Correct.
So in number 8, didn't we make the bottom number opposite? Or
A is the number 2, so opposite that would be negative, and B is negative 3. So negative over negative makes the positive. That's why you don't see the negative in that one. Good question. Okay, let's revisit point slope form, okay? Point slope form went pretty well on the game there, but this is our point slope form. Biggest thing to remember with that is that you're given a point, and because of the minus signs in the equation, that point appears opposite, okay? So I'm just gonna pick number 4 to do here, okay? So PT, that means given. What's the given point? So we go, all right, well, how do I find that? It's the x1, comma y1. x1, y1. So the x1, it looks like -2, but the minus is part of the equation, right? So the x coordinate is actually +2. And what's the y coordinate? +3. Because you got to remember, okay, the minus signs are part of the formula. So actual x is 2, actual y is 3. So that is the point that we plot first. 2, 3. Okay, instead of starting at an intercept, we're starting at that point that we're given. Okay? Okay, and then the slope is the m given in the problem, so that's 1/2. Okay, and so then we're just going to graph that slope, just like slope-intercept form. So up 1 over 2, run out of room, go back to that given point, down 1, left 2, down 1, left 2, and there we go. All right. Okay. Now, you're going to notice underneath this, it says standard form. So additionally, we need to be able to graph, but we also have to be able to like translate in between the forms, okay? So this question is asking us to take this point slope form equation and write it in standard form. Remember, standard form is ax plus by equals c, where a, b, and c there's no fractions, right? There's no parentheses, no fractions, and also a can't be negative, okay? So they have to be integers, but a has to be a positive integer. So we gotta somehow take this and turn it into that. So we're gonna have to do a lot of like algebra wizardry here, okay? I'm gonna rewrite this, y minus 3 equals, and if you run out of space, like you can bleed over into this one, because I'm not going to do this one, okay? So y minus 3 equals 1/2 times x minus 2. Okay, so I need to take that and turn it into standard form, okay? Well, standard form does not have any parentheses, all right? So what could I do to eliminate the parentheses? Distribute the 1/2, yep. So I can do that, and then I won't have parentheses anymore, okay? So I have y minus 3 equals 1/2 times x is just 1/2 x. And 1/2 times, remember that is a -2, so half of -2 is -1. Okay? All right. Now remember, there's lots of routes we can take to get here, but you got to think, all right, I don't have any parentheses anymore. But I do have a fraction, and standard form doesn't have any fractions. So there is a really easy way that we can get rid of all fractions. Okay? Anybody know how to get rid of any fraction? Anytime, anywhere?
Reciprocal. Reciprocal.
Okay, both of those things are right. You can multiply by the reciprocal or the denominator. Okay, you multiply by the reciprocal when you want to like cancel out the numerator as well. We don't really care about that. We just want to eliminate the denominator. So we'll multiply by the denominator. So if our denominator is 2, everything gets multiplied by 2. So that gets multiplied by 2, and that gets multiplied by 2. Okay? So we just have to do the denominator. We don't have to do the reciprocal. Okay, so now I'm gonna distribute my 2 on both sides, right? So I'm gonna have 2y minus 6 equals 1/2 x times 2. Isn't that just 1x, right? Or just x? And then negative 1 times 2, isn't that just minus 2? Everyone okay with how we get here? Distributing the 2? Okay, now, goal is to be standard form. So I notice x and y have to live on the same side of the equal sign, and my a has to be positive. So if I move x over here, it'll be negative, right? I don't want that. So it might be easier for me to move 2y over here, because I need x and y to be living on the same side, right? So why don't we subtract 2y, and then we're looking at negative 6 equals x minus 2y minus 2. Oh, goodness. Is it charging?
Yeah.
Oh, okay. All right. Okay, so x and y are living on the same side, but we want all the constants on the other side. So this negative 2, we can move over here, right? We can add 2. Whoops. So negative 6 plus 2 is negative 4. All right. Now, I know it's backwards, right? We have c equals ax plus by, but that's okay, because we can use the transitive property and just say, hey, I can just,
Thank you.
yep, swap sides, x minus 2y equals negative 4. And that's standard form. X and y are on the same side. We don't have any fractions, and a is positive. Okay? All right. It's kind of the new stuff there. It's kind of the new things. What questions can I answer about that? You have a chance to practice that in a second, and we can go over it in a second as well. All right, horizontal and vertical lines. We did pretty well in that game, so I'm gonna skip over this at the moment, but these are our notes for that. Here's what I would like you to do. We have a few minutes. I want you to take this "you try" section and just pick and choose. Just try some of these. And before you leave, I'm going to put up the answers so you can just check yourself. Okay? And then when we get in tomorrow, you can ask questions about anything we didn't get to just now. Okay? But take, we'll go about 3 minutes to just pick and choose some to try, and then I'll show you the answers. Okay?